Nimbus 7 satellite was launched in November of 1978 with 7 instruments on board, including the total ozone mapping spectrometer known as TOMS. TOMS measures the total thickness of the ozone layer by looking downward from its orbit at 955 kilometers to observe the backscattered or reflected ultraviolet radiation from the Earth. Nimbus 7 satellite is in a sun-synchronous polar orbit with a 102-minute period. Successive orbits are displaced by 27 degrees in longitude. The instrument looks downward toward the surface of the Earth. Directly below the satellite, it has a 50-kilometer square field of view and scans across the track of the satellite to fill in data between successive orbits. The thickness of the ozone layer, measured in Dobson units, at any point will be indicated by the color. The maximum or greatest thicknesses are approximately 490 Dobson units and are shown in red at the top of the scale. The scale then goes through the colors towards the blues, indicating less and less total thickness of ozone. The extreme lows in years after 1979 will be noted by the pinkish or light violet color. The occasional large white patches are values greater than 490 Dobson units and can be used as an indication of extreme high values. The data is displayed in a south polar projection with the pole at the center. The circles shown in white are at 60 degrees south latitude and 30 degrees south latitude, and the outer edge of the circular picture is the equator. Note that on October 2nd, 1979, we see a typical pattern of a very large maximum located off the pole of greater than 490 Dobson units. A minimum near the pole is shown in blue, indicating approximately 250 Dobson units. The minimum on this particular day is pushed somewhat off the pole and is distorted into an elongated form. In this picture, the outline of the Antarctic continent can be seen. The Greenwich meridian is toward the top of the map. The date is shown at the very top. We will now proceed through 7 successive Octobers. The first day is October 1, 1979, followed by a 3-day sequence for that year. This will be followed by October 1980 and so forth up to 1985. The motion of the highs is indicated by the red and occasional white regions which rotate around the low with about a 1-week period. The elongated minimum varies in its depth, but is generally about 250 Dobson units and rotates along with the maximum. October 1980 again shows the pattern of a high region surrounding the low region. The minimum is somewhat more regular in shape in this year, indicating less dynamical activity or disturbance. '81 was an even less disturbed year. A very symmetrical behavior of the minimum is seen with the fluctuations in the maximum still occurring, but not distorting the minimum nearly as much as in other years. '82 was a very dynamically disturbed year. Very low values, less than 190 Dobson units, indicated by the pink, are now being observed. In 1983, the area of extremely low values below 190 Dobson units is larger than in 1982. The pattern, although not as disturbed as in 1982, does show the low center being pushed off the pole. 1984 shows a continuing growth in the area of low values, and in fact, lower absolute values as the darker shade of pink appears near the pole. The surrounding high also has decreased. No longer are the very deep red and white shades present. In 1985, the high regions continued to show even less total ozone than before, and the lows are significantly deeper. The October monthly mean maximum and minimum values in the southern hemisphere are 100 Dobson units less than they were in 1979. What is happening in 1986? The first satellite data indicate that the minimum has again appeared, but the large total ozone decreases of recent years have paused. The data for October 10, 1986, shown here, has an area of low values similar to previous years with a minimum of 163 Dobson units. This is greater than it was in 1985 on the same day, but less than in 1984.